All right, algebra students, Mr. Peterson here. I am out for today, so I recorded this lesson for you guys. Today, what we are up to is we are taking a look at 1-5, A and B. And usually when I'm gone, I like to record a video for you showing you how to do the lesson. That way, hopefully it makes more sense. Then you can watch it in class, you can rewatch it at home. And it's better than trying to learn it on your own through the textbook. Okay, so my goal is to hopefully have this help you out. All right, here's the two warm-up problems I gave you. If you did those, let's take a look at the answers to that. First problem, we would want to combine our two like terms. We got our 3x over here and 2x. Combine those together, you get 5x. Then you got plus 12 is equal to negative 18. Then you got a two-step equation, cancel out the 12, divide by 5, and you end up with x is equal to negative 6. All right, check out this other one on the left over here. Start off with first distributing the 7. Okay, so when we multiply what's inside the parentheses by 7, we get 7x minus 28 is equal to 2x plus 12. Then we got to cancel one of these x's off, cancel off that 2x first. Then you're left with 5x minus 28 is equal to 12. All right, then you got a two-step equation, cancel off the 28. Okay, then divide by 5, and you end up with x is equal to 8. All right, a few problems we've already done just to see how you guys could do with those skills. Okay. What we're up to today is we're going to solve one-step and two-step algebra inequalities. Okay, now the good news is it's the same exact steps as solving one-step and two-step equations. They just look a little different. Okay, so for example, a regular algebra equation would be this: x plus 7 is equal to 11. Okay, those are problems we have solved so far in class. An algebra inequality would look like this: x plus 7, almost the same, but then you would have something like this: less than 11. Okay, so you have one of those instead of an equal sign. It just replaces the equal sign. Okay, good news, the same steps apply for solving this inequality as this guy over here. Okay, so let's take a look at the different inequalities we could have. There are 4 different types of inequalities that are out there, the symbols we can use. We can have the symbol pointed this way, and that would read A is less than B. Okay, because we got the pointed symbol there, the small end of the symbol is pointed toward A. So we'd read it as A is less than B. Okay, it always reads from the left to the right there. Okay, so if we take a look at this next one, we got A is greater than B because we got the bigger part of the symbol with A. This one here, A is less than or equal to B. All right, this little part right there, it's half of an equal sign. That means it could equal B or it's less than B, one of the two. And this last one over here, A is greater than or equal to B. Okay, so we got the bigger part with A, so A is greater, or it could be equal because we got half an equal sign. All right, those are the 4 that we're going to see as we kind of go solve some equations. All right, so let's take a look at solving an inequality. So first, let's go back to something we know: solving an equation. All right, if we had x plus 3 is equal to 9, this is a one-step simple equation. We would go minus 3, and that would get us x is equal to 6. Okay, and that would be our answer. X equals exactly one number, 6. One number and one number only. Only 6 is the answer to that. All right, let's take a look at what happens with an inequality. Same step. We would cancel out the 3, cancel the 3 over here, and what we're left with is x is less than 6. Okay, notice how this pointed part is with x. That means x would be less than 6. So I'm going to rewrite it: x less than 6. Okay, so what that means, I got it covered up here. That means x is, we need to erase that part, 6 And that right there, 6, change that. Okay, so now our solution is x is less than 6. That means x can be any number that is less than 6. Anything smaller than 6 would work. So like a 4, like a -2, like a -11, anything smaller than 6 is a possible answer for x, because x can be any number less than 6. Okay? So what we also do is we graph what the answers to this would look like. Okay, so here's some examples. If we take a look, so if x is less than 5 on this first one here, x is less than 5 would look like this. We would put a circle on 5 on a number line, and then we would draw an arrow going this way to show that x could be any of these numbers less than 5. Anything smaller than 5, we would draw an arrow to show that as a possible number x could be. All right, here's another one. X is greater than -1. All right, see how the big side of the symbol is with x, so that would read x is greater than -1. Okay, so on a number line, we would circle -1, and then we'd draw an arrow going to the right to show that x could be any number that is larger than -1. Okay, take a look at this next one. X is less than or equal to 1/2, because we got part of that equal sign. All right, so how we would show that this, because x could either equal 1/2, because we got that there, or it's going to be less than 1/2. So it's either going to be equal to 1/2 or less than 1/2. All right, to show that, we would do a filled in circle at 1/2. Okay, notice how these other ones didn't have a filled in circle. The filled in circle tells people that x could be that number. It could be 1/2, or it could also be anything less than 1/2. So we would draw an arrow to the left to show that it could be smaller than 1/2. All right, so you got a couple options. It could either be exactly 1/2 or less than 1/2. And we use that filled in circle to indicate that. All right, if we're going the other way, look at this one. X is greater than, or it could equal 0, because you got that half of a equal sign. All right, so we would put a filled in circle on 0 to show that x can equal 0. And then we'd also draw an arrow to the right to show that x could also be anything bigger than 0. All right, so that filled in circle tells us it could be that number that we circle. All right, so let's solve some and we'll graph some, and it'll make some more sense as we go along and do that. So it's going to be one of these 4 different options here that we graph. All right, so let's check out some problems. We'll solve them and we'll graph them. So here's our first one. X plus 12 is less than 20. So let's go ahead and solve it. It's a nice one-step equation. So we're just going to cancel out 12 by doing -12. And if we do that, we have x drop down the same exact symbol, and your answer 8. Okay, so you got x is less than 8. All right, so to show that on our number line, we're going to draw a quick little number line. We're always going to put 0 on the number line, and then we're going to put the number itself that we have for a solution. So we would put 8 somewhere over here to the right of 0. All right, now to graph it, because it doesn't have that equal to part, we're going to have open circle on 8. And then x is less than 8, so we're going to draw an arrow that goes to the left to show that x can be any number smaller than 8. All right, and that's how we're going to graph it in this class. We'll put the 0, the number where it would go, and then we'll put wherever our arrow is going to go. All right, let's check out some more. Okay, here's another one involving decimals, a one-step equation. Let's cancel off the 0.3. So we're going to add 0.3, and we'll add 0.3 to this side. All right, all these steps are just like normal equations. Cancel that, and you have n is less than or equal to 1.2. Okay, so notice how this is written kind of backwards. Instead of having the n over here on this side, it's over here. Okay, so we can turn that around. All right, if we turn it around, make sure you look how the point is with n. So that's how we're going to rewrite it. We're going to say n, and then the point needs to be with n, because that's the way it looks right here. And then we have 1.2. All right, if you turn it around, it makes a little more sense. All right, because now we have n is less than 1.2, and we can go ahead and graph it. All right, so we're going to draw a number line, put our 0, put down our 1.2. Okay, and then take a look at what you need to do. It has part of an equal sign, so that's going to be a filled in circle on 1.2. And then we have n can be less than 1.2. So we're going to take an arrow, and we're going to go this way to show that n could be anything smaller than 1.2. All right? So again, if you're going to turn that around, if the point is with n, you want to keep that with n when you turn it around. Okay? We'll check out some more. It'll get more familiar as we practice some more of them. All right? Try these ones on your own. See how that goes. See if you can solve them in graph one. Problem B, because it's backwards, you want to turn it around when you get to your answer. That'll help you out. So see how you guys do, and you can pause the video, and then we'll check our answer here in just a couple of minutes. All right, let's take a look and see what you guys came up with for this. Okay, so this first one-step equation. All right, we would cancel out that 1 by going -1, and we're left with s is less than or equal to 9, because we got the point there with s, so it makes it less than. All right, so to graph it, we'd want to draw our number line, filled in circle on 9, and then we're going to go to the left to show that s is anything smaller than 9. All right, now this one here, we got 12 on this side, we have t on the other side. You can graph it just the way that it is written, like that, or you can turn it around. Notice how the point is with t, so that's how I want to write it. I want to be t less than 12, and that might make it a little easier for you to graph it. Okay, so that means we're going to have an open circle on 12, and since t is less than 12, we're going to arrow over everything smaller than 12. All right, so you can always turn it around the other way. Just make sure you turn your symbol also when you turn that around. Okay, some people like to have it like that. All right, let's check out some other ones, and we'll see what we got. Okay, so here's one. We got 7x is greater than -42. So we're going to solve this. It would take one step. We would need to divide by 7, divide by 7. All right, it's just regular algebra rules here. Okay, so that's going to get us x is greater than -6. So there's my answer, and it's turned the right way. X is greater than -6. The bigger side here is with x, so that says x is greater. So we'll graph that out. 0, -6. All right, and we want an open circle on -6, and we want to show everything greater than -6. We'll have an arrow going to the right. Okay, we'll try another one. All right, we got 2.4 is less than or equal to m divided by 3. So if you got this fraction like this, it means division, like we've talked about. So we're going to go times 3 to cancel it, and we're going to go times 3 to this side. All right, so we're going to multiply 2.4 by 3. Okay, and when we do that, 2.4 times 3, we'll take a look at what that's going to give us, and we're going to end up with 7.2 for an answer. Okay, so 7.2 less than or equal to m. All right, now it's backwards, so let's turn it around. Okay, so take a look. Your bigger part is with m, so that's how you want to rewrite it. So you're going to have m, put the bigger part with m, and 7.2. And then now we can graph it. Okay, so m is greater than 7.2. Let's go ahead and put that on a number line. All right, so there's 0, there's 7.2. It has the equal to parts. We're going to fill that in. And m is greater, so we're going to draw an arrow going to the right to show that it's greater. Okay? Try some other ones here. Oh, we got this fraction here. 3/4 times r is less than 12. Okay, we're going to get rid of that fraction. There was a trick I showed you guys in a few lessons back about how to get rid of that fraction is you multiply by the common denominator. And we only have one fraction, so we only have one common denominator, and that would just be 4. Okay, so we're going to multiply this entire equation by 4 so that we can get rid of those fractions, and it'll make it a lot easier for us. Okay, so we're going to go 4 over 1 times, and we're going to multiply that by 3 over 4. Okay, so I just had to put a 1 under that 4 to multiply over here. And if I multiply straight across, I get 12 over 4, and that simplifies down to just a whole number 3, which is what we want. So 3 is going to replace 3/4. All right, I'll put my symbol down. Now you got to go 4 times 12. So 4 times 12 is going to get you 48. All right, so we'll put 48 right there. Okay, so now that we got that, then now it's just a nice equation without any fractions. So we'll divide by 3, divide this side by 3, and we're going to get r is less than 16. Okay, so there's our answer. It got rid of the fractions. Now let's graph it. So get a number line here. We have 0. We have 16 somewhere. And then let's see, we got r is less than 16 because our point is there with r. Okay, so open circle on 16, and we're going to go to the left to show that r could be anything smaller than 16. All right, try those two out on your own. All right, see what you can do. Here's that same type that we just got done working on. We can get rid of that fraction. If you throw, because you got a 4 there, you can put the 4 out there. All right, see how that works out, and then we'll take a look at your guys' answers. All right, let's check this out, see what it would work down to. Okay, so your first step over here on this problem, you're going to divide by 4 on each side. So you get k is greater than 6. All right, so here we got it graphed. All right, you got open circle on 6 and an arrow going to the right. And this one here, we're multiplied by that 4. So when we do that, 3/4 turned into 3, and 27 turned into 108 when we multiplied that by 4. So then we just got to divide by 3, and we get g is greater than 36. All right, so here we are, open circle on 36, and then an arrow going to the right to show everything. G could be anything bigger than 36. Okay. All right, now there's a rule that happens, a small little math rule that we got to remember, and it happens when we're dealing with inequalities, and it'll happen anytime you multiply or divide by a negative number. Okay, when that happens, your inequality symbol is going to flip, and it's going to go and point the other way. All right, it's a small rule. It's hard to remember it. A lot of people forget it, but it's one of those things that it can make your answer incorrect if you don't remember it. All right, so anytime we multiply or divide by a negative, our symbol is going to flip the other way. Okay, so let me show you a couple examples. Look at these two problems. They almost look identical except for that negative symbol with the 12. Okay, so if we were going to solve it, let's start with the one on the left. We would divide by 12, okay, and we would get x is greater than 7, and that would be our answer. Okay, now over here, if we solve it, it almost does the same thing. We're going to divide by negative 12, and we're going to divide by negative 12. Okay, now here's where that rule comes in. Because we are dividing both sides by a negative number, so anytime we multiply or divide by a negative number, we still write down x. This symbol is going to turn and point the other way. All right, and it's going to make that x is less than negative 7. All right, it just makes a turn and go the other way. All right, to kind of remember it, I come up with this silly phrase, a flipperoo. All right, so our symbol does a flipperoo anytime we're going to divide or multiply by a negative. All right, some reason that word sticks with people and it helps them kind of remember that. All right, so as we go solve our next problems, we're going to spot when we're going to use that flipperoo to make that happen. All right, that's a good word, flipperoo. Okay, so let's check out this one. Now we got some two-step equations with inequalities. So let's just go through and solve them like a regular two-step equation, and we will see what we get. So if we were going to solve this, we would go minus 45 to each side. Okay, so just like that. And after we do that, we're left with 2b is greater than, and this would work out to be 16. All right, so there's step number 1. Step 2, divide by 2, and we're going to get b is greater than 8. All right, and we didn't have to flip the symbol at all because we didn't multiply or divide by any negative numbers, so we're okay. All right, our steps were the same as a two-step equation. B is greater than 8, so let's graph it. So we're going to put our line here. We have 0, we have 8. We want an open circle on 8, and we want to show that b can be anything greater than 8. Okay, so we're going to go to the right of 8. Okay, we'll try some other two-step equations. All right, let's take a look at this one. Our first step would be to cancel out this positive 8, so we would go minus 8. Okay, when we do that, the 8 cancels off, and we're left with negative 3y is greater than or equal to 21. Okay, so there's step 1, just like a regular equation. Then we're going to divide by negative 3, divide this side by negative 3, all right, and check it out. Because we're dividing both sides by a negative number, that's going to cause our flipperoo to happen there. Okay, so we're going to get y, and we're going to have to turn that symbol around, point it the other way, and we'll get negative 7. Okay, so we have that symbol flip that took place. Now let's go ahead and graph it. So y is less than or equal to negative 7. So we're going to draw our number line. Okay, we got 0. We have negative 7. And because of the equal to part, we want a filled in circle on negative 7. Okay, and then we're going to go to the left to show that y could be anything smaller than negative 7. All right, try this one out on your own, see what you come up with, and then we'll take a look at what you got for an answer to that. So go ahead and pause it and then check your answer when you're done. All right, let's take a look and see what this would come out to. All right, regular two-step equation steps. Cancel out the 6, so you're going to go minus 6. That's going to get you minus 18 over here on the left. Divide by 3, and you end up with a negative 6 on this side. x on this side. All right, no symbol flips here. Okay, we could turn this around if we want. So x is with the pointed side. So when we turn it around, we want to make sure that our pointed side is with x, and we have -6. Okay, so that helps out a little bit. X is less than -6, so filled in circle on -6 and arrow going to the left. All right, I believe that's it for our first section of notes here. Let's take a look. Yep, that's it. That is all we got. All right, so your assignment is, we just got done with lesson 1.5a, so you're going to work on this assignment here. See how those go. You got 1-step and 2-step inequalities to solve and graph. Get that done in class, show your work, and then after you get that assignment done, you could play the 1-5b video, and then you got this assignment here for homework. All right, and all that stuff is on Google Classroom, so that you can take a look at that. All right, so go ahead and start on that, see how that goes, and then when you get done, check out the 1-5b video, and I'll show you guys some more inequality stuff. All right, thank you for watching.